8-1 functions. On this slide, I'm going to give you the technical definition of a function, and on the next slide, I'm going to break that definition down into more easily understandable parts. So, a function is a special relation in which each member of the domain is paired with exactly one member in the range. From chapter 2, we know that the domain are all of the x coordinates, and the range are all of the y coordinates. This definition of a function translates into there cannot be more than one y coordinate for each x coordinate. Technically, that's what a function is. Now, in the center of the slide, we have several blue dots on a graph, just random dots on a graph. These dots form a relation. It's a group of points. Sometimes we're interested in 3 of them. Sometimes we're interested in all of them. Either way, they are a group of points and they form a relation. So the technical definition of a function is a special relation in which each member of the domain is paired with exactly one member in the range. A function is a special relation in which each member of the domain is paired with exactly one member in the range. From the last slide, right here, we have a relation is simply a group of points on a graph. The relation could contain as few as 2 points on the graph or as many as all of the points on the graph. But a relation is just points on a graph. The domain is a list of all of the x coordinates for all of the points in the relation, and the range is the list of all of the y coordinates for all of the points in the relation. So a relation is a group of points, the domain are the x coordinates, and the range are the y coordinates. And down at the bottom in the large letters, in reality, a relation is a function if there are no doubles in the domain. So it's very, very important to be able to see the relation listed in some form like this, where you have the domain with a bunch of numbers and the range with a bunch of numbers, and you are simply going to look at the numbers in the domain. If there are doubles, meaning the same number occurs more than once, then it is not a function. If there are no doubles in the domain, then the relation is a function. We are not interested, it does not matter what the range looks like. Pay no attention to whether there are doubles in the range or not. It's meaningless. It only matters in the domain. So we'll move on to the next slide, which shows a couple of examples of this. Actually, 3 examples of this, because these are 3 different ways the information will be presented to you throughout looking at functions. So if we look at the first example over here on the left, we have the domain and the range listed out. The domain is -1, -2, -2, -6. Those are the list of numbers that we're going to pay attention to. You're going to look to see if there are doubles in the domain. Does anybody see doubles in the domain? There are 2 -2's in the domain. This is not a function. Because there are doubles in the domain. All right, so the first one is not a function because there are doubles in the domain. There are a pair of -2's. Does it matter that there are 2 5's and 2 1's in the range? No, it doesn't matter because we're not paying attention to the range. We only pay attention to the domain in this case. In the middle example, we no longer have the word domain and range. We're just given the x and the y. And on the left-hand side, where the x is, those are the x coordinates. And on the right-hand side, those are the y's, where the y coordinates. And they can be paired to be put points on a graph. So again, we will look at the domain, the x coordinates. Are there any doubles? We have a 14, a 15, a 16, a 17, and an 18. This is a function, yes, because there are no doubles. So this one's a function. We successfully found a function and not a function. And then finally, the third method of having information presented to you will be the coordinates presented to you as ordered pairs or points to be put on a graph. This one, you'll again look at the x coordinates. We have a -2, a 4, a 24, and a 5. Is this a function or is this not a function? This is a function because there are no doubles in the domain. So pretty straightforward as far as determining if a relation is a function or not. We have doubles in the domain. It is not a function. If there are no doubles in the domain, then it is a function. This is the more mathematical way of looking at whether something is a function or not. There is another way to determine if a relation is a function, and that's if the points are actually already on the graph. These points are listed as points. On this slide, we have points actually on a graph. And we're going to use something called the vertical line test. And the definition and how to use a vertical line test is right here. With a vertical line test, we're going to pass a vertical line, or a pencil in your case, through the graph from left to right. If the vertical line touches the relation in only one place at a time, then the relation is a function. If the vertical line touches the relation in more than one place at a time, then the relation is not a function. So I have two graphs here for you, and I have my vertical line here, and what I'm going to do is I'm going to take my vertical line and overlay it on my graph, and I'm going to start at the left edge and I'm going to slide it across to the right like that. Do it again a little bit slower, and as we go through, you can see that I'm going to stop right there, and you can see that the vertical line touches the blue dots, and it only touches one blue dot at a time. So far this is a function. So I'm going to grab it again and slide it some more, still only touching one dot, still only touching one dot. Now we have a problem because it's touching 3 dots in a row. This is no longer a function because the vertical line is touching the graph in more than one place at a time. And these 3 dots happen to be right next to each other. I will move the line over a little bit further so that you can see that it touches dots in more than one place at a time here. Now, we can do this with dots. We can also take a pen and draw the relation and then pass the vertical line test through it again, and you can see that it crosses in more than one spot on several occasions. So this first one here is not a function. The second graph we have over here is with the red x and y axis. We have the black diagonal line, which is going to be what we're going to test. And we're going to take this vertical line, and as we're just going to drag it across, you see it begins to touch the function right there at its left edge. And as we drag the vertical line across the function, we see that it only touches the relation in one place at a time. So this one is a function. So you have 2 ways of determining whether a relation is a function or not. You have the method that uses the points where you have to look for doubles in the domain, and you also have something called the vertical line test. Both ways are very useful. Your homework is on pages 371 and 372, problems 12 through 30, the evens.